These are the lesson 3.2 notes for Math 6 and Advanced 1 on writing algebraic expressions. When we are writing expressions, remember that's a math sentence with no equal sign. There are some words that are really helpful because they imply certain math operations. So if you see these words, they can give you a clue about whether we're talking about addition or subtraction or multiplication or division. So this is a good chart to kind of memorize or have where you can see it. Some good addition words are added to or plus, sum, remember that sum means addition, more than, increased by, a total of, or and. All of those words might be associated with addition. Subtraction might be subtracted from, or minus, the difference of, that's the math word, less than, decreased by, fewer than, or take away. Multiplication might say multiplied by, or times. It might say product. Sometimes it will say 3 times or twice, or my personal favorite, of. Remember that of means to multiply. And division will usually be either divided by or quotient of, and I might add to that. Sometimes it'll say something like groups of. If you're taking groups of things, especially if you start with a total and you're splitting it up into groups, that would be a division problem. Right? So it starts by just having you write expressions using numbers, numerical expressions. So we're going to write the phrase as an expression. You do not have to find the answer. You're just writing the expression. 8 fewer than 21. Okay, well, I know that the words fewer than mean that I'm going to subtract, but this one's a little tricky. If I have 8 fewer than 21, then I have to start with 21 and subtract 8. That's not because the bigger number, that you have to take the smaller number away from the bigger number, because you know that we could have a negative number as an answer. Negatives are okay. It's because of the way the words are phrased. If we have 8 fewer than 21, then I have to start with the 21 and take away 8. So you need to read the problem carefully to decide what order to put them in. The product of 30 and 9, let's see, product is a multiplication word. Product of 30 and 9. You may write it with the parentheses, or you can write it with a dot. We are going to move away from the times sign because the times sign looks like an X. And now that we're doing a little pre-algebra, we don't want to confuse our times sign with an X. So either parentheses or a dot. Right? There are 2 U tries. Okay. And now we move into writing algebraic expressions. So now instead of just having numbers, it will have some letters, some variables in it. 14 more than a number X. And this is another trick. When you start looking at algebra problems, they will almost always, they'll tell you what the variable is. It'll be right after the word number. It'll say number X, or sometimes it will tell you what that variable stands for. You'll see that in the word problem in just a minute. 14 more than means I'm going to add. If I want 14 more than the number X, then I must have to start with X and then add 14. So this is another one of those that is kind of backwards from the way you think it might be. A number Y minus 75. This time I can just work straight across. I can say Y minus 75. If it had said a number Y less than 75, then you would have had to put 75 minus Y. Okay, and then the quotient of 3 and the number Z. Quotient is a division word. Quotient means to divide. And so I need to get these in order. So I'm going to either write it as 3 divided by z as a fraction, or I can write 3 divided by z. Either is correct, but this is where we want to be moving. All right, this is how we write algebra. All right, you have 4 you tries, and then we have a couple of word problems. Your friend has 5 more than twice as many game tokens as your sister. Let T be the number of game tokens your sister has. Write an expression for the number of game tokens your friend has. So the first thing that I do, first I read it a couple of times. So let's read it again. Your friend has 5 more than twice as many game tokens as your sister. Okay, this part looks pretty important. 5 more than twice as many. And in this part, let T be the number of game tokens your sister has. And then write an expression for the number of game tokens your friend has. So the first thing you do is what we call defining the variable. It's telling what the variable stands for. All right. And I just write that over to the side. I say T equals the number of game tokens that your sister has. All right. And then it says that my friend has 5 more than twice as many. 5 more, let's see, more than, that's an addition word. And twice as many, that's a multiplication word. Twice means to multiply. So I have 2 operations in this one. So if I take the number of tokens that my sister has, I want twice that many. That means I'm going to multiply that by 2. And then 5 more than that will be plus 5. This is an expression for the number of game tokens that the friend has. Friend has 5 more than twice as many. Okay, so steps that you want to go through. First, just read it to yourself once, more than once, twice, 3 times. Underline the important parts, the parts that are telling you the operation, the numbers, and then what the variable stands for. Then write down what the variable stands for, and then kind of work backwards to figure out the expression. Okay. And we have one more here. So now we're going to plant a cypress tree that is 10 inches tall. This is a really small tree. These are those tall trees that people plant along their fence line. They get really tall, and they use them kind of as privacy fences. Okay, those tall trees. Each year, your tree's height increases by 15 inches. So the first thing I'm going to do is to make a table that shows the height of the tree for 4 years. And then I'll use that table to write an expression for the height after T years. See how they define the variable right after? They'll tell you what the variable is and what it stands for. So T is the number of years. This is like the workbook page that we did today, right? All right, so let's start with the number of years. That's going to be T. And the second column will be the height. And that height is in inches. Okay, so when we start, the tree is 0 years old and it is 10 inches tall. And then after 1 year, it is 10 plus, see, each year its height increases by 15. So it would be increasing by, it's 1 year times 15. Okay. We can write that out to the side because it is going to ask it to find the answer. 10 plus 15 is 25. After 2 years, and we still have it started out as 10, and now it's grown 15 inches each year for 2 years. So it's got that repeated addition idea. 2 times 15 is 30, plus 10 more is 40. And if I look here, 25 plus 15 does give me 40. See, 3 years, I've got 10 plus 15 times 3. The order of operations tells me to do the multiplication first is 45 plus 10 is 55. And after 4 years, 10 plus 15 times 3 equals 3 times 15 is 45. Whoops. What did I don't think we need 3 again, huh? 15 times 4 is 60, plus 1 more is 70. Okay, so you can see that it's going up by 15 each time, which makes sense because it's adding 15 inches each year, right? So then when we want to write the expression for the height after t years, we end by putting the variable there in the chart. And then we look to see what is the same all the way through. 10 is the same all the way through. That's a constant. The tree started at 10 inches tall, and that doesn't change. It was always 10 inches tall. And the plus sign stayed the same all the way through. The 15 is the same all the way because it grew 15 inches every year. But this number, the number of years, is changing. This is the variable because it's changing, and they tell you that that variable is t. So the thing that is changing goes right there. Right? So the problem will tell you which variable you're using and what it stands for, and then you write the problem, and the things that stay the same are still in the final expression. There's the constant, there's the coefficient, the number that goes in front of the variable, the number that's being multiplied by the variable, and then there's the variable. Okay, then we can use this expression to find the height after 9 years. So we write down t plus 15, 10 plus 15 times t, and we want to know how much that will be when t is equal to 9. You substitute in for that variable. And then, if you've gotten a calculator, you are allowed to use calculators now, but this one is also on your multiplication chart. You can do 15 times 9. That's 135. Plus 10 is 145. 145 what's? 145 inches. Okay, and then your U-try is very similar to this one, but we want to know how much taller it will be after 16 years. Okay, and then here are the answers to the U-tries. So you can pause there and go back and check your answers. And if you missed one, then look and see how you missed it and make the correction, right? Because we're interested in fixing things and seeing how we made the mistakes, not just in putting down a right answer.